Hey, welcome back everyone to the Black Brain Trust. This is episode 172. I'm here with my co-facilitators, Lionel and Nagone.
What's going on, Mike? How you doing today, Nagone?
What's going on? What's going on, Lionel? What's going on, Mike? What's happening?
All right.
Chilling, man. Chilling, man. It's good to have you all on. All right, so tonight's topic is Black Tech Talk and amateur space launch vehicles. We got a docket and description beneath the video. Make sure you hit the like button as you come in and share if possible. To kind of recap on what we were talking about last week, because this is a follow-up. Um, we were talking about cube-based satellites and Raspberry Pis, as well as uh, uh, lunar rovers. NASA put out a document a document on their GitHub that allows you to use those blueprints to design your own rover, lunar rover for Mars. So you can actually build your own, and it costs about $2,500 to actually build from scratch. Um, and using the Raspberry Pi, which is a single board computer or SBC, with Linux, and actually a cube-based satellite that can actually that's about the size of two cans of soda could be utilized for satellite communications, and it's roughly anywhere between $500 to $25,000. So this hangout is actually based on the launching of these items into space. So
Mike, I have a question, and I think this is just maybe for the audience as well. What are we talking about? What would be the net costs, say, in launching one of these satellites and putting them, let's say, on Mars, or putting a satellite into space right now with this given program? What are we kind of looking at in dollars and cents? I know might vary, but could you kind of elucidate upon that a little bit more?
so it depends on capacity, right? So Russia charges the United States $88 million per seat on their Roscosmos space vehicle or space rocket. I've seen cost anywhere as low as $20,000 per item, something to that effect, $20,000 to $25,000 per item. So it's doable if you have the resources, but there's also alternative methods such as weather balloons and amateur space rockets. An amateur space rocket would consist of something that's at least 10 feet tall, that has enough thrust to get off the ground and actually make its way up into low Earth orbit, which is LEO. And what that would allow you to do is to have a one-time launch vehicle to deploy that cube satellite or that payload up into the lower stratosphere of space. The highest stratosphere is something like 200 miles up.
Okay. So you're talking about going above the ionosphere and all of that. Is that correct?
Correct.
All right. Yeah, I was watching a very interesting movie some years ago. You might have seen it, called Black Sky. I don't know if you remember that movie.
I haven't heard of that.
Black
I know. Have you heard of that?
No, no.
Yeah, it was about an amateur rocketeer, and he was able to design a rocket himself. Basically, went out to basically out literally out to the salt flats, and launched this vehicle, and apparently it went well into space, and he had cameras looking out that showed him that you could really literally design your own rocketry at home and launch and get into space. So he was actually looking to design a rocket that would carry him into the black sky as well. So people have been on top of this for well over 30 years. So it's kind of interesting that we're talking a little bit more about that now, because that's talking about rocketry and delivering payloads out into space is an idea for the amateur that's been around for quite a while. So if one is able to do this themselves, I would think it would be uh, quite a bit cheaper to do. But are there any restrictions, let's say, from the government and so forth in doing this?
Not necessarily. So that's why the Q-based satellite was actually designed, so that you could actually put something as small as that into space, and not actually worry about the litter. So, the litter or debris of having um, what they consider to be space junk in orbit. Either it falls back down into Earth, or it causes litter around things like the space station or other satellites that are adjacent to it. But these things are so small, they're almost inconsequential to the rest of the objects around it. So let me get to this first article on the docket. All right, this first one is from africanews.space, or Space in Africa. Africa could soon be launching its first satellite from its soil. Commercial space launch service is a rapidly growing subsector of commercial space industry. The subsector, which is projected to hit $7 billion market size by 2024, includes spaceports, launch vehicles, navigation services. A spaceport, sometimes referred to as cosmodrome or a launch site, is a ground-based launch facility for. This Africa site is actually a premium site, so I'm not logged into it to actually get all of the article, but I wanted to bring it up because Africa is on the forefront of space technology right now. This little map that you see on the side is all of the space-related institutions in Africa right now. There's over 24 happening right now. There's a space race inside Africa, and there's probably about eight of the 54 countries have over 3 satellites in space already. And many more are slated to come on by 2020 and beyond. So we see that Africa is on the forefront of getting to the next level. There's even discussions about Africans going to the moon. So that was recent. Lionel, you have anything you want to add to this?
Yeah, as you stated before that continental Africans are at least 20 years ahead of um, Black Americans, African Americans. And this is a contribution to what you said. This goes on your side, where you have Black Americans, which are quote unquote the richest group of Africans on the planet, but now you have other groups of Africans catching up with us, not only in finance, but now they are surpassing us in technology. Now they have dozens of space startups and businesses launching or about to launch space satellites, Q satellites, and putting men on the moon. No longer can you say, "Oh, they live in huts or they do this." That is not even the case, not even close to the case. So this is
Yeah,
great news.
yeah, that's pretty critical news. And one of the things I know we talk about African Americans and the richest and so forth, but as far as a nation is concerned, these are countries that are that have a vested interest really in getting involved in the space race for the survival of their country, of their nations. And this is a function of national security and so forth. So they have to get there. So yeah, they're definitely going to put a lot of effort and time, to certainly get there. I've always known that they've had the infrastructure, or the academic infrastructure, because I remember over at Syracuse, Link Hall, the College of Engineering. That's all you saw there were Africans, Ghanaians, and Nigerians, and so forth. That's all you saw that was there, and these guys would be walking around, You could tell they were distinctly African because they looked a little different than us, but they were, they were in the most, challenging and more difficult, science classes, and they were rocking and rolling. So they definitely have a more vested interest. I would think here in this country it would be great if we were pushing that a lot more. But our big problem that I do see with us right now, especially from an academic perspective, is many of us are not pursuing careers in the sciences and the technologies, especially the hard mathematics and the hard, the physics and so forth. We're not in the mathematics. We're not pursuing that at the level like the Africans are doing. Those who are getting educated are doing in Africa. We definitely need to push that a lot more.
Mm-hmm. Mm-hmm. So I want to bring this map up here, and this is from the same Space in Africa website. So there are several space research organizations that are engaged in activities related to outer space and space exploration in Africa. And according to the business and market analysis of the African space industry done by Space in Africa, over $3 billion has been spent on space projects in Africa since the launch of the Nowsat 101 by Egypt in 1998. We have created a list of African countries with space agencies. While some countries have established space agencies backed up by national laws, some countries have research centers that coordinate space activities in the country. And what we're looking at right here is, we'll start from the top, from the north, Morocco, Algeria, Tunisia, Libya, Egypt, Sudan, Ethiopia, Kenya, Zimbabwe, South Africa, Angola, Gabon, Nigeria, and Ghana. So there is a space race in Africa that is happening right now, and as Nagon was saying, literacy is a big issue. People are still not taking this stuff seriously enough. This is a part of the whole entire fourth industrial revolution, where emerging technologies that are going to be on the forefront of your next emerging economies are taking place right here, right on the continent, and we're not keeping up from the American side, from the Black American side. So,
Yeah, I would like to, as far as the maths and sciences, be a part of something like this channel. How we have a group of people together and everybody teach one another through what we do, some type of way, in terms of this with the space and sciences, math and sciences, be a part of something where if these high sciences and math, everyone learn it, and next thing you know, a year, maybe two later, we are highly skilled in math and science in order to go ahead on and do this.
Yeah, that's an absolute fact. We could start teaching kids this very young. Last year, when I was doing this year, I haven't been doing it much, but last year I was doing a lot of it. And we had classes where we were dealing with just even Einsteinian principles about gravity, difference between the Newtonian side and the Einsteinian side of what that really was all about. Breaking it down very simplistically, they were able to catch on to this quite easily. There's a lot that these kids can pick up. We got to start them pretty young, and I think we really have to start these kids literally. And I know people will look at me and say, "You're crazy." Start these kids with higher level mathematics at the ages of 9, 10 years old, maybe even younger. Show them what a derivative is, and just start with this kind of stuff. Literally start them out after they learn how to add, subtract, and divide. Start to get them involved in algebraic functions, and begin to get them involved also with some aspects of integration and differentiation. They can pick this up. They certainly can pick this up, and learn certain rules and so forth. Because they can play puzzles and they can play these video games. They can learn this stuff a lot earlier than a lot of us are giving them credit for. And we need, that's why I think Yeah, I think that's why we have to start, to start taking over our own education, get them out of some of these public school systems, and start showing and just get these kids. Once they're able to successfully add, subtract, and divide, then you start adding algebraic functions. Then you start bringing in, what a derivative is. All right, the slope intercept method, these types of things. You start to show them the stuff on graphs. They can pick this up a lot earlier than you can ever believe. Anyway, go ahead, Mike.
Yeah. No, I was just gonna say that I started with computer electronics or electronics specifically with soldering and some form of robotics and radio controlled vehicles when I was 6.
Yeah,
So by the time I was 11, 12 years old, I was putting together things and taking apart TVs and radios and stereos and stuff like that. And I could actually repair those things before I even got into middle school. So I think a more hands-on approach is um, applicable for boys than it is for girls. Boys they tend to be more physical, so allowing them to, if you give a person a Rubik's cube, they'll figure it out. Especially as they're young, they'll keep fiddling with it till they get it right. But I do agree with you that there should be some form of process of walking them through early advanced mathematics. I know for NISB, for National Society of Black Engineers, there is a pre-K 12 program. Pre-K 12 is to walk kids from preschool all the way up until their senior year of high school on a STEM path of science, technology, engineering, and mathematics. Walk them through that path so that they have a consistent um, worldview of what it is that they're trying to do from an engineering standpoint.
yeah, but also make it fun to where these kids can understand it applied to music and a lot of other things, and you can show them just how things really work. I remember one of the more successful tutoring sessions I had some years ago was showing a kid um, how the how the planets moved actually played a very key role in actually in music, and he couldn't understand what I was saying until I played for him Johannes Kepler's Harmony of the World and played the sound of the planets moving that he had, and then their orbits, and the space age sound was produced on something that something that he wrote almost 400 years ago, and here was this space age sound being written 400 years ago. The kid looked at it in amazement, but these kind of things actually you can do. There are a lot of ways to get through to them, and I just think it's something that we just have to just put our heads to and just start doing. And it would take a national effort, I think, but we need to take advantage. We need to take hold of of the education of our kids. We need to take it over. I don't. The public school system. I believe in public schools, in the fact that my father and all of us, we were all educated. My parents were all educated this way, but it's failing in our communities now. We're going to have to make some changes, and I think we have the tools, even by way of the internet and so forth, that this could easily be done, and train people out. If we need to start training people at home, we need to do that. But I think the tools are there for us to really take advantage.
Yeah, let me get to this next article. This next one is from Space in Africa. 101 steps towards getting involved with space-related activities. Review of space-related institutions in Africa. I'm not going to read this whole thing, just to give you a synopsis. Space-related activities are growing rapidly in the African continent, a trend evidenced by the rapid adoption of Earth observations by various countries in the continent. This at this has at least been the case for the past 8 years. African countries are seeing the need to adopt space technologies to help solve the pressing problems such as climate change, food security, national security, and all other related issues that are facing the continent in the 21st century. There are, however, obvious reasons why most African countries haven't been on the map or known for any significant space technology events. The high investment and initial capital needed to kick off a space technology project was one of the fundamental issues in other myriads of issues. However, the tide is now changing due to the development of various hardware and software technologies. These are propelling the development costs effective Earth observation tools afforded by most countries around the world. We have increasingly seen a myriad of partnerships across the continent and from outside of the African continent. These partnerships are mostly focused on hardware, software aspects, as well as capacity building for nationals from various countries in the African continent. Capacity building has been particularly fundamental due to its contribution to the countries lacking in country experts on big technology transitioning fully, fully to having autonomy in their own programs. This also contributes to solving problems unique to a country instead of just general space technology applications. There is hence a huge potential in terms of homegrown solutions to be implemented in the big technology industry in the African continent, given its raw and yet to be fully exploited domain. There is potential to have national level as well as country level solutions, a move that the African Union is pushing for with the objective of countries benefiting from the different space technology programs. In this report on a strategy and policy adopted in 2016, the African Union states its mandate in providing the support on the strategy and implementation of the technologies for the outer space in African continent. And they go on to talk about examples of GIS and remote sensing courses. That I was actually going to get to that, but it doesn't take much to actually get into this from the ground level. So let me go to EDX and let me show you something real quick. Oh, that's not it. Not the term I was looking for. So on EDX, there's a plethora of Division 1, Division 2, Division 3, Division 4 courses provided via this website that you can take to actually get involved in space research or planetary research. And most of these courses, let me see if I can find the one that I had saw before. Yeah, so there's quite a few of them. Most of them only take a few months at best to complete. Let me see if I can find the no, it's not it. Anyways, when I find it, I'll post it in the chat. But for the most part, geospatial, computer engineering, planetary science is another one. Most universities now have that available. You can take all that stuff online, and I believe that there's a few courses on NASA's website as well that you can actually take. NASA has put out a lot of great information for everybody to adopt. So, Lino, you have anything you want to add to this? 101 steps towards getting involved with space-related activities.
Yeah. When we say as Black men we need to get into these things, this is not an open-ended comment. We're actually showing you the different ways, a plethora of different ways to get into this field. We're giving you multiple resources to go to, such as edX, such as NASA, such as the GitHub, such as the articles that we put in the description, the same articles we go over, and the people that are listening to this can actually read those articles, and it may be some things in those articles that will lead you, excuse me, lead you to other places that will give you more in-depth information that can guide you, at least, at the very least, build a foundation of knowledge and skills in order to get into this field.
Great point. Excellent point.
Mhm. You have anything to add to this, Nicole?
No, I would just, absolutely piggyback on what on what Butterlade just had to say. He broke it down exactly. There's a lot of information that's there for you really to get into, and we just need to start to take advantage of it. But putting that out there and letting people know where it is, you can really start to, you can enter this. You can enter this, and it's a lot easier than a lot of us would think. This is right there. It's kind of at your fingertips in some ways. Am I right, Lionel?
You are
Nope.
correct. You are correct.
Yeah, yeah. So that's yeah. So I'm definitely just literally just piggybacking on that. Anyway,
All right. All right, this next one is from Space in Africa again. A deep dive into Nigeria's space sector. I was wholly out to research space startups in Africa this week. I was curious to understand how private ventures get involved in space in capital intensive and usually government led sector. The curiosity was similar to looking for startups who are commercial banks. I found out that there are private sector players in the sector, especially in South Africa. However, the twist played out quickly when I discerned government agencies in the space sector in Africa as startups. Eric Ries, in his book Lean Startup, which is actually a good book, you guys should actually read that, defined a startup as a human institution designed to create something new under the condition of extreme uncertainty. He further mentioned startups are just a series of crazy experiments. The veteran entrepreneur emphasized the condition of uncertainty, experiments, and limited resources as core features of a startup, not number of years, size, and funding. This context resonates with Nigeria's National Space Research and Development Agency, NASRADA. NASRADA, the principal space technology agency by the government, was established on the 5th of May 1999, saddled with ambitious task of developing Nigeria's space science and technology program. Nigeria in 1976, during a joint session of the United Nations Economic Commission for Africa and the Organization of African Union, first expressed its ambitions to join the elite League of Nations with outer space programs. Preparatory policies followed between 1976 to 1980, leading to the establishment of a 10 million naira national remote sensing center, which started operation in 1996. A blueprint of what later became known as Nasrada was contained in the National Space and Science Technology Policy drafted by a nine-man committee. The National the National Space Research and Development Agency had an initial runway of $93 million with a goal to develop and promote the use of space technology as a key driver for socio-economic development. In 2001, the Obasanjo-led administration adopted the space policy. May I suggest that the difference between Nasrada and Eric's model startup is government support for the former. Nasrada had unwavering government support in its early days with a whopping $93 million initial runway, which is over 200% more than the $39 million 2018 allocation for the agency. Nasrada did not delay in inducting Nigeria into the elite league of nations when it launched its first satellite, Nigeria Sat 1, on the 27th of September 2003. NigeriaSat-1, an Earth observatory satellite with a 32-meter resolution camera and an optical sensor, was built by a UK-based Surrey Space Technology Limited and launched from Russian Plastek spaceport. NigeriaSat-1 outlived its expected lifespan of 7 years. In 2004, the Nigerian government ordered for NigComSat-1, Africa's first communication satellite from China Great Wall Industry Corporation. So it's a picture of one of the satellites for coming out of the space module that Nigeria has set up. This is just putting more emphasis behind what we have been talking about on here. We've been talking about basically 1 in every 3 startups will be a space startup, and putting emphasis behind the idea that this is a goal that can actually be attained if we put some emphasis behind it. And you, like the article was saying, you're joining the big leagues when you start putting things into space. You're no longer a third world nation anymore. You're now up there with the developing and first world nations. Nogon, you have anything you add to this?
No, I think that that's right on. I think when you're really moving towards space and developing space, putting satellites in, which also is going to move you, I think, closer to even potentially going to the moon and going to other areas to actually mine space, means as far as that part of the fourth, industrial revolution is concerned, you're starting to get into the fifth and sixth. You're a huge player. You're a big player because now you're in the let's put it like, let's lay it on the line. You're in the big money. So that's kind of what's going on. So the African nations are definitely moving there aggressively. Which I find quite interesting is also how you don't hear about. I mean, we're hearing about here the news. You're looking at it, but you see kind of in the mainstream news in other areas, you don't really hear about it that much. So I find that also quite interesting. And people looking at Africa as very backwards and somehow this dark continent that is full of backwardness and savagery. It's quite a bit different when we start to begin to look at what we're really looking at.
Yeah, absolutely. And when they said $93 million, that's something I see as very attainable. I know the Black community spends millions of dollars on cosmetic goods such as hair and weave. So if we can actually just go natural for a few, if we can just go natural for a few years, this is actually something that could be done.
Yeah, this
I know you have very
attainable.
Yeah, it is. I agree with you. It is very attainable. And when you said that we spend as a Black community large amounts of money on certain things, I just went and got my haircut today, and I saw ridiculously long eyelashes. I saw weave that it's clearly not yours. I saw tattoos. I saw branding clothes. I saw a lot of things that that is not part of a capsule wardrobe. These are things that you have to continuously purchase over and over and over again, and that adds up. The bad food eating trends that we have, and those things that, like you say, if we were to stop this for temporary amount of time, these are things that are attainable that can bring wealth to the Black community at large. And I have to agree with you.
Mr. DE, what is going on, brother?
Hey, I'm gonna drop off for a few minutes. I'll be back.
I'm good, man.
Good.
How's everybody doing?
Doing well. How are you?
Brother Nagon, how you doing, man?
Good, man. Good, man. How are you doing there, brother?
Right.
You have anything you want to add to this, DE?
I'm kind of I when I first started out airline business, like I started out like 1981, and after I got established a little bit, I like started going to schools and trying to encourage little kids to get involved in encourage them to get into the airline business. Whether you want to be a pilot or a mechanic, those are the two I was pushing basically because management is good, but I could see the way things were going, and I wanted to kind of help prepare our young people for it. But it was frustrating. It became very frustrating to me that all the classes that I went into, New York, even here in Florida, with my kids, schools, my kid might be the only one in the class that was black, was interested in airplanes. All the black kids would be somewhere else doing something else, and they weren't interested in it. Their parents wouldn't let them get interested. Me, I let my frustration kind of get out of hand, and I said, you know what, throw up my hand and forget about this. This is ridiculous. So I stopped doing it. The other thing is, like Africa can do a lot more because the technology, um, even though you can take old rocket technology and use it. All the America, Russia, China, India, we can glean from all the experimentation that they did on their rocketry. And if we knew to put new electronics in, we can get the electronics from them also and put it together and build our own rockets. But like you were talking about Nigeria, Nigeria is a land where they got so many people who need work, and this kind of business can they can take a lot of those kids, even the adults. They got adults that went through 4 or 6 years of college and come out and not working. There are millions of them on the street in Nigeria that have college degrees and can't find work. And if you put all these, the research that went into all this stuff, they can put these people into it and make good use of it. So me, this when I see this thing, it gets me frustrated. So it's kind of like trying to encourage people to do things that for some reason they don't want to do, and I say, you know what, I can't help it. When they're ready, there'll come a time when they will want to do it, and I wouldn't have to encourage them. So let me stop.
You make a pretty good point. I was just thinking. I was just going to say very quickly. I looked in Germany back during World War II, where they developed the V rocket, the V2s. They were developing rocketry then, over 70 years ago, and they weren't using any types of microchip or any other type of advanced solid state technology type of electronics or
process.
Yep. None of that kind of stuff. They were just literally, designing a rocket that came from Goddard, who actually, really talked about rocket technology, so forth, literally in the teens and in the 20s of the 20th century, and designed his talking about his rockets. They were rejected. And the Germans took it and ran with it, and here we are. So go ahead. You gonna say something, Mike?
No, I was going to say that the Atlas rocket that the United States first launched into space actually came out of Germany, came out of Nazi Germany.
Yeah, yeah, absolutely. That's absolutely. Werner von Braun, he was their guy, and he was a Nazi, but his whole view was, I'm involved in this Nazi game because these guys got the cash and they can help me do my rocketry the way I want to do it because no one else is, and we can get way ahead on that. And they weren't using supremely advanced technology, so
And keep
this should be something supreme that could really work for us, because the knowledge is out there. Been out there a while. Anyway, go ahead.
Yeah, I was just going to say that keep in mind that the Russians were working on rocketry in the early 1900s. They had launched their first rocket in 1913.
Yeah, yeah. I mean,
the Americans didn't think that that the Europeans or even the Russians had that sort of technology available. They were 25 years ahead of the United States.
I mean, let's just be frank with it. We first started seeing rockets being launched, a couple thousand years ago with the Chinese. They were literally blasting off very small missiles, and they were actually using them in warfare, and Sun Tzu and them talked about that over 2,500 years ago. So this is nothing new, and this is something that we should be grabbing and taking advantage of in a big way, because the technology is out there. It's well known, and Africa being on top of this, developing it. Yeah, but I have to say we should be here from a technology or small African American technology company. We should be developing a lot of rocketry right now. We should be deeply involved in rockets and deploying satellites. We should be deeply involved in this. Don't know why we're not. But anyway, go ahead. Go ahead.
Yep, let me get this next one. This next one is space in Africa. Overview of CanSat technology in Zimbabwe. So this is a picture of a pseudo CAN-based satellite. Or what's supposed to be a CAN-based satellite. Tapping into global technological advancements would also aid the country's industrial agenda as the country strives to attain a middle income economy by 2030. So Apt was the president of Zimbabwe, Emerson Mnangagwa, as he implored on the nation to take a science and technology-based trajectory in order to move at par with the rest of the world. Indeed, in this era of science plays a critical role as humanity transforms to a new technology-informed order. There is no turning back. Honorable Minister Aman Mawara is a record stating that the establishment of space agency is not a drill but is real. That's a Michu D. Science technology is changing the way we see, do, and think about all the things we have known since birth. All we have known is changing at an astounding pace. Does it mean that we have become novices all of a sudden? Not really. We have two options to adapt or think. We talked about that earlier, Nagone. The article draws you. This article draws you to an innovation in science technology known as CAN satellites and various benefits it brings forth. The Minister of Highway and Territory Education, Science, and Technology Development said establishment of Zingza would take a phased approach. The nation was enlightened that in Zimbabwe will build a satellite that will be used as a launch pad for the sustainable development of the country. One of the first phases in the development of satellites development of CAN satellites is mainly done in secondary schools and tertiary institutions. CAN satellites or CanSats is a small and simple satellite that fits in a 350 milliliter can size, 66 millimeter diameter, and 150 millimeter height. It has a mass below 350 grams. The idea of CAN satellite came through discoveries by Professor Bob Twiggs, Stanford University Space Development Laboratory in 1998. He suggested a concept of developing small satellites that fit in a 350 milliliter can and have a mass below 350 grams. Many would wonder why they should bother themselves with trying to understand CanSats. One would certainly ask which part of their lives can satellites be of relevance. CanSats perform a number of functions, and their missions can be taking pictures, transmitting telemetry, atmospheric missions, video capture, imaging, communication, and navigation. Satellites have changed human habitation on Earth since the first satellite was launched in 1957 by Arthur Clarke. Satellites have been used for weather, navigation, television, broadcasting, internet, remote sensing, Earth exploration, education, disaster recovery, and scientific research. I'm not going to go into too much of this, but this is Zimbabwe's approach that they're teaching this in grade school now. They're not waiting like Nagon was saying. Nagon was saying to bring that you should be training your or educating your kids at very early ages with advanced mathematics. So that's what they're doing here, and this is in Africa.
If I can sit here and tell kids that are 11, that are less than 11, 9, 10, 11 years old, the difference between, Newtonian physics and Einsteinian physics, or really talking about the difference in what gravity is from a Newtonian perspective, and then from a Einsteinian perspective, where one really describes the motion of something, and then we now begin to talk about the Einsteinian side, where now we're talking about, in fact, a shape that causes a certain type of effects, which can be somewhat considered somewhat abstract, and yet 9 and 10-year-olds can understand this. Listen, we have to take another look at how we're really showing kids science and more advanced principles that they can pick up on quite easily that we assume that they cannot. I've done this myself. So if I'm done it, and I'm no massive super teacher, I'm just a decent guy who understands this stuff, and kids kind of like me. But somebody who really has superior talent in being able to teach this could do wonders with youngsters in this regard. And this is something that we're just not putting a lot of effort into in our community, which I find bad. But these guys are dead on it. They're dead on it. But they're dead on it. They understand that. They understand this. So,
DE, you have anything you want to add?
D, you there?
I think that you stepped away. That's fine.
Oh, okay. Yeah, but that's pretty awesome news right there, Mike. Like I love hearing that. Just love it. Anyway, Go ahead. Go ahead. On to the next.
Yeah, let me get to this next one. All right, this next one's is about a rocket. This is based on Wikipedia's reference. So it's a ICBM that the Soviet Union had developed under the Ukrainian agency. Basically, it's a space launch vehicle named after a river. It is a converted ICBM used for launching artificial satellites into orbit. So these same rockets that were used for intercontinental ballistic missiles to deliver payloads of nuclear weapons are actually being converted over from nuclear strike vehicles to actually space launch vehicles. It's very effective because they're functional, and two, they've already been built, and three, it's cost effective. The research has already been done on it. So let me get to the next.
I want to say very quickly. I mean, looking at the ICBMs. I mean, when we look at our Apollo space missions, taking people to the moon, we were basically putting astronauts on the tip of an ICBM and blasting into outer space. That's what we were doing.
Yep. All right, next one is from spaceflightnow.com. Photos converted Russian ballistic missile fires into space with satellite. This is it right here. Just read the caption real quick. A decommissioned missile originally built in Russia to deliver nuclear weapons to intercontinental targets in the United States vaulted out of a vertical canister Friday and fired into space with a European satellite to monitor global air pollution. The 95-foot tall rocket booster took off from the Placetic Cosmodrome in northern Russia. The Sentinel-5P satellite enshrouded atop the rocket is set to begin a 7-year mission measuring atmospheric chemistry, helping produce the daily air quality alerts over every major city on Earth, and feeding data into an archive that will help scientists, governments, and companies conduct climate research and respond to emergencies. This is actually really interesting because when you take into consideration that you can actually buy these vehicles from these governments, a lot of them, I think the North Koreans actually bought their stuff from the Ukrainians too. At one point, they were buying parts, or they were buying pieces of hardware and intelligence to actually build their own rockets. So everybody who played with these ICBMs were basically on the forefront of getting their space program in order. Same thing with the Iranians too. You can put the Iranians in the same category.
Yeah, it seemed like the ICBM, that was the kind of the platform to really to really get into the space race, and that, quite frankly, came out of the development literally from NASA, and Werner von Braun was one of the was the top was at NASA was the top basically director engineer who really helped to put that whole space platform, that rocket platform together, which nonetheless was based on the old V2 rocket technology. Isn't that interesting?
Mm-hmm. Yeah, I know that I saw one about the Scud missile being used as a low Earth orbit space vehicle, and those were put on the auction block. Some years ago after the Soviet Union collapsed, they had so many of them. They produced like thousands of them, and they got put onto the auction block. You could actually buy them without the warheads in them. If you look at Yemen has quite a few of them. I think they have something like 500 those Scud missiles that they brought out of the archives, brought out of their bunkers, and actually fired them into Saudi Arabia to defend themselves. But they could actually be utilized or repurposed for space exploration if you were to actually re-engineer it to do so, retool it.
Yeah, and there's a lot of it. I mean, they had a lot of stuff coming out of Russia. I mean, they had submarines and all the kind of stuff like that were coming out of there. But as far as high tech was concerned, or technology with respect to space, they're deep, and they were smart to take advantage of it. Smart to take advantage. It was on sale, and it was for pretty cheap, from my understanding as well. It was fairly inexpensive.
Mm-hmm.
So,
D, you have anything you add to this?
Is he there?
Maybe he's muted and doesn't realize he's muted. DE, if you can hear us, you can unmute yourself.
Is he there?
Yeah, I'm not sure what's going on. We'll come back around to him. All right, I just wanted to show this one article here. This is a image shot of Iraq, North Korea, and Iran's space launch vehicles. And what they're doing is they're comparing them in these images.
Yeah.
You see any similarities?
Yeah, expand. Make it a little bigger. I see any similarities, yeah.
See, and it says it right here. It is from the same Scud system that countries like Iran, Iraq, Pakistan, and North Korea modified to extend the range of their early offensive missile programs. From these modified systems, Iraq and North Korea forged ahead by clustering their longest range missiles and stacked them to create what was at the time a long range missile program in disguise, or at least the start of one. Iraq's Al Abid never really went anywhere, while North Korea's Taepodong 1 and later Taepodong 2, also known as UNRWA Galaxy class SLV, would initially be replaced with a missile system like the KN-08. So they were basically using these old Scud missiles to build their space program out of them. And I think they failed. I think North Korea failed quite a few times, maybe about 5 or 6 times before they got it right.
Yeah, but they've been getting it right because they've been firing quite a few of those things around over Japan and stuff like that for the last few years.
Should just fall right in the ocean, right?
Yeah, I mean, they would do that on purpose, so they would let you know their rocket technology game was on fleek, and they were ready to rock and roll. So, very interesting.
Mm-hmm. All right, let me get to this next one. All right, this next one is from hackday.com. Building homebrew VTOL rockets, vertical takeoff launch rockets. That's what VTOL stands for. No one can deny what SpaceX and Blue Origin are doing is a feat of technological wizardry. Building a rocket that takes off vertically, goes into space, and lands back on the pad is an astonishing technical achievement that is literally rocket science. However, both SpaceX and Blue Origin have a few things going for them. They have money, first of all. They are building big rockets, so there's a nice mass to thrust cube law efficiency bump. They are using liquid fueled engines that can be throttled. Joe Bernard isn't working with the same constraints as SpaceX and Blue Origin have. He's still building a rocket that can take off and land vertically, but he's doing it the hard way. He's building a VTOL model of rockets. Most of these parts are 3D printed, and he's using solid motors you can buy at a hobby shop. This is the hard way of doing things, and Joe is seeing some limited success with his design. So while the rockets coming out of Bernard Propulsion Systems looks like models of SpaceX test vehicles, there's a lot more here than looks. Joe is using the thrust vectoring system, basically mounting the Estes motor in a gimbal and attached to a pair of servos. This allows the rockets to fly straight up without fins or even the launch rod to use to get the rocket up to speed in the first few milliseconds of flight. This is active stabilization of a model rocket with the inevitable comments of the ITAR violations following soon afterwards. What were you going to say?
Wow, that's interesting. So it's got variable thrust. So that's kind of like what they were using on. I think we see that on I think on the Raptor F-122s, F-22s, and so forth. And then we have this one vertical takeoff kind of aircraft that we have right now. So now you can do vectored thrust technologies to kind of put these rockets in orbit without fins and so forth. That's wild. Is that what is that in fact what they're saying? Is that what they're saying? Wow.
Yes.
Wow. And this is just wow. Okay. Anyway, go ahead. We can do this at home. Okay. Very interesting.
I just wanted to play this video real quick. I mean, it looks authentic, but obviously it doesn't. Obviously, it's not going to carry any payload up, but it's still the ability to manufacture something like this in your own or.
Yes, that's wild.
Yeah, we'll give it some time.
Indeed.
Come on, launch the vehicle already. It's taking this thing so. All right, here we go. Wow.
Wow.
Like it failed to it failed on second stage or something. It looks like what happened.
Looks like it.
I'm not entirely sure. I think Complex probably knows more about this than I do, but I expected it to either come down on its own and return back to the pod, or to at least make second stage. But my point in showing this is that at the lowest scale, this can actually be done, right? So
certainly can. This guy's blessed out in open field. Something he these guys are launching themselves. Okay, it's pretty good.
Hey guys, I'm back. I watched that guy. I watched his video. I normally watch his videos, and he came out with he has almost perfected that thing. He's like 90% ready. What he has done is he can separate launchers. He can go to a second stage, and he sells a control that he can use to control the nozzle, the direction of the nozzle, so that he can, without the fins that normally rockets use for flight control, he can use the nozzle on the motor to control keep the nose of the rocket in the upright position, and that's what he was testing there, and it failed. That's like I think that's about the third or fourth time that he did it when that one failed.
Oh, so you're saying so the thrust vectoring failed on him. He was trying to use that to thrust vector the rocket, and that failed when he attempted that. Is that what you're saying?
Yes, that was one of the failures. But right now he's got it. He's got a Saturn V with the with the two rockets on the side of the vehicle that fall off, and it goes up and then comes back down. He's even got one rocket now that comes back down and lands in the upright position.
Mm-hmm.
In the upright position?
Yeah. Yeah, it comes back down just like a SpaceX rocket would, like a Falcon 5 would.
Wow. Okay, it's pretty good. Anyway, go ahead.
Yeah, I was just gonna say that this could actually be controlled with a Raspberry Pi and an Arduino. So Arduino is a single task single board computer. So basically, you give it one instruction and it does it. So if you gave it the instruction to launch second stage on the booster on the engine, then that's exactly what it's going to do. And then the other mechanism that you can have is to detach the other side boosters that's on there, and you can control it through a Raspberry Pi through what they call a GPIO, general purpose input output controller. You plug that in, and the Raspberry Pi would have a set of instructions that you already gave it to follow these functions. And it doesn't cost much. We talked about this last week, but I'm just recapping on stuff that we were talking about because you wasn't here. But basically, a Raspberry Pi only costs $35. It's a very micro computer. All you got to do is load the software up, give it the instructions, and it will actually work 99% of the time. You connect the Arduino boards. You connect the Arduino board to it, and it's going to do even more. So now you take all the processing capabilities from the Raspberry Pi, you distribute it to these Arduino controllers, and now you have a full stage autonomous vehicle for the most part. There's also AI code that's readily available for you to download and actually implement it into this Raspberry Pi. So now you're talking about launching a vehicle like that into space at a larger scale, but you can also get more return on your investment because now you're not worried about the communications gap, right? You already have a set of instructions in place that for it to do what it needs to do at a very small, efficient cost. So that's where we are.
That's pretty impressive.
Mm-hmm. Yeah, it is. All right, let me get to the next article. All right, this one is from hackday.com. If you are planning on building your own space shuttle, one of the most complicated machines ever built was the U.S. Space Shuttle. Technically, the STS, or Space Transportation System. Despite the title, we doubt anyone is going to duplicate it. However, one of the most interesting things about the shuttle's avionics, the electronics that operate the machine, is that being a government project, there is a ridiculous amount of material available about how it works. NASA has a page that gathers up a description of the vehicle's avionics. If you are more interested in the actual rocket science, just back up a few levels. We will warn you, though, that if you've never worked on space hardware, some of the design choices will seem strange. There are two reasons for that. First, the environment is very strange. You have to deal with high acceleration, shock, vibration, and radiation, among other things. The other reason is that the amount of time between design and deployment is so long due to testing and just plain red tape that you will almost certainly be deploying with technology that is nearly out of date, if not obsolete. A good example is the Orbiter's GPC, or general purpose computers. There are 5 of them. At least 3 have to agree before they do anything. Early versions of the GPC used magnetic core memory. That technology was old even when it was put into design, but it was the best way during the design phase to ensure the memory would not be upset by radiation effects. In 1991, a major upgrade did replace the core with semiconductor-based memory. The information on the NASA site is a bit high level, but still detailed. If you want some real hardcore discussions about the shuttle's avionics, the K Lab lost NASA site lost NASA funding before moving to private web server to remain operational. If you ever wanted to try your own hand at programming and how, as the shuttle programmer did, you can get the documentation there. There's also a booklet with a lot of information that you can download from NASA and a video overview you might enjoy below. So basically, NASA has put the blueprint up for a space shuttle. And we talked about this last week, but they also put the blueprint up for the lunar rover. And the Cube-based satellite actually came out of NASA and I think the ESA. So what I'm saying here is that there's a lot of readily available information on how to get this done. It's just a matter of human capital.
You say human capital. You talk about also people being people just getting involved in this. Is that correct?
Correct. This is the page that NASA is referring to. For the shuttle itself. If you look at the top, it's talking about. Let me see if I can zoom this in. So basically, they've put all of the documentation up for how to build your own space shuttle.
Wow, that's kind of interesting because a space shuttle would also mean that you could re-enter into the atmosphere and deal with those, I guess, the, shields and all that, heat shields and all that of being able to deal with that as well safely without burning up. That's a because we did have some issues with that with some of the older shuttles, but how would that problem be reduced?
Well, because they've already done the work, right? They've already done the testing. They've already done most of the work. Everything else is just already documented. It's just a matter of taking the pieces that actually are applicable. Like they say, multifunction CRT display system. Well, we don't use CRTs anymore, right? We all use LCD.
That's correct.
TFT-based screens, right? So now we're one step ahead, if not a couple of steps ahead, based on the evolutional change in technology.
True.
Mm-hmm. DE, you have anything to add to this?
Quite a bit ahead in some.
I think DE's away right now.
Wow, space shuttle. That's pretty cool.
Sorry, I was just looking up the guy's site and pulled up the rocket information on the rocket launch where you can see it. And also, he has a kit that you can put on your own model, and it will separate the rocket, and it will guide your rocket. It will do what you want with the rocket. The same thing that he did with his rocket to perfect it. He's selling the kit that does it right now. Yeah, I put it in the chat. I put the
okay. Let me see. Oh, you put it in the put that link inside the group chat here. And then I'll paste it in.
Oh, shoot.
Because you don't have the capabilities to drop a hot link in the chat. So.
Okay.
Yep. Okay, I got it. Okay, I got it. Let me drop this in there. All right, let me get to the next article. All right, this next one is from motherboard.com. Building self-landing replicas of SpaceX rockets. This is from the same guy, Joe Bernard, but just an article that's basically covering the same thing. I'll read the first couple paragraphs. As the founder of Bernard Propulsion Systems, BPS, a small business making flight hardware for other amateur rocketeers, the 25-year-old Nashville resident is working on cracking propulsive landings for model rockets. This is the same principle that allows SpaceX to land the first stage of its Falcon 9 rockets after boosting a payload to orbit, but it has never been demonstrated in hobby rocketry before. The key to propulsive landings is thrust vectoring, which enables control over the direction of a rocket's engines during flight to change its trajectory and stabilize the vehicle. Bernard is a pioneer in do-it-yourself thrust vectoring, and in the last few months, he's harnessed the technique to test self-landing model-scale rockets. As some of the most recent videos on his YouTube channel demonstrate, there are still a few kinks left to work out, but it's pretty impressive what he's managed to accomplish so far. So people are acknowledging his capabilities. Definitely something to pay attention to. Let me get to this other thing that I want to show.
Good evening, everyone.
Hey, what's going on, Ulysses?
Chilling.
You're very low.
Okay, how do I sound now? Sound better?
Nagone, can you hear?
Complex.
Yo. Oh, wait, hold on.
Yeah, I can hear him. I can hear him.
Mm-hmm.
Am I coming in low?
Yeah, you're very low.
Just a little bit. Just a little bit.
Okay, I'm outside, kind of out hanging out with my daughter, but I did, because Joe Bernard was basically what I was going to do the discussion on. But how do am I coming in low?
No, you come in a little better
now.
now.
You sound good. You sound
Okay,
good
I think
now.
I just need to talk louder. But I'll go ahead and let you guys continue, and then you kind of covered a lot, but I'll just kind of touch into detail because I've been following what he's been doing for about a year. So yeah, I'll just give my inputs on it later.
Put your inputs on it now, man. Go ahead.
Yeah, because we're at the end of the docket.
Oh, I thought you had an article you're about to cover.
No, I was just gonna bring up one piece, but yeah, just give me a second.
Okay.
A complex. I put his I put the one I put two videos of his on the chat, and one is it with the where the Saturn V boosters where he
Yeah.
separates them,
Mhm.
and the other one is where he shows how he did the thrust vector.
Yeah, I was gonna. Well, I'll go ahead and just do it right now. I'm gonna post it here. Wait, hold on. Let me-
All right, I found the link I was looking for. So let me just share my screen real quick. I didn't know that it was actually Virgin Orbit. Basically, they have a jumbo jet that actually launches their satellite into space right off the wing. You can see right here that the launcher is on the side of the jumbo jet itself, which launches a small satellites or incube-based satellites into space from that area. So that's the alternative method from rocketry, from a rocketry standpoint.
Shoot, that's pretty good. They don't have to worry about booster failures, and I mean, wow, if they perfect that, they could save a ton of money of launching instead of doing Earth launch.
It makes a lot of sense. It simplifies the platform a lot easier. You know, like I said, it leaves a lot less room for certain kinds of error and problems. So it definitely makes a lot more sense to do that.
Yeah.
Yep.
I mean, as long as it's not as long as it's not a Boeing 737 Max.
Oh shit!
Yep.
It's a Boeing jet, but I don't know which version of Boeing they use.
That's the. It
So
looks
that's
like
787.
no, that one like 400. That's the 747-400.
Okay.
So,
But yeah, that's the alternative method to launching in space. I think that's a very doable mission. I don't know what a jumbo, what a jet like that would actually cost, but it's actually probably could set Africa into a different perspective for launching satellites into space. Especially with the way the continent is structured, you can actually fly from the north and actually get it off quicker because it's just almost closer to the North Pole.
You save a lot of. I mean, your rocket be smaller. You save so much
Yes.
from. Oh man.
Complex,
you have something you want to add?
Yeah, man. Just with regards to Joe Bernard, so this is one of those interesting scenarios where there's a guy who's gone about doing a good bulk of like the legwork with regards to like development of scaled rocketry, and the way his platform is set up is that it's largely open. So what you purchase when you buy one of his kits is you purchase it's the Signal R2. It's the motor controller system. You know, the dual servo system that does the thrust vectoring of the motors. And then it's all app based. It's all app control. So he developed the app, and then there's the onboard computer. And I forgot, it's Blip and Blop. I think that's what he code names them, but it's two different variants, but they do the same thing. But and then there's also the mounting hardware. So you buy the mounting hardware, like, you know, the thrust vectoring servo kit. You get all of like the core components, and then what you can do is you can begin to develop. You incorporate that into your own scaled rocket designs if you wanted to, or you could basically use his. But you know, and the plan of what I'm looking to do, you know, 2020, I want to start making customized fuselage components and stuff like that, using different types of materials. You know, Mike, we had talked about it before, using, you know, various types of composites. And so the tensile strength of these would then determine, you know, how high of a flight you could take these things because of the size of the motor that you can then stick in them. So, you know, what I'm saying is that it's not out of your reach when we talk about these things. And that's why I wanted to profile him, but I'm glad that, you know, you'd already touched on a few articles about what it is that he does. And like what DE is saying, like I said, I've been following the dude for like probably a little over a year. And as he's developed it, I started to get my ideas on some things where I'm like, okay, I can just basically take what he's doing and then, maybe make like, some carbon fiber or hemp fiber fuselages, do some, more exotic things, And this, so when we were talking about launching like mini cube satellites and stuff like that out of vehicles like these. See, so it's not like exactly out of your scale or reach to start doing these things on a smaller scale, and then you just scale up from there. But it was his company that I wanted to, and him in particular, that I did want to profile. And what I posted was a link to the playlist of all the videos. So if you watch the playlist, he literally goes from the time he began to all the way to where he's at now in each venue. So if it's like the re-entry landing, self-landing of the re-entry, if it's the deployment, or if it's the thrust vectoring, getting the trigonometry correct, he covers it all. He even covers all the mistakes, and then he tells you about what he did to correct them. That's why what D was saying, like, this dude is like, you just see him, he just cranked right through, and he's like literally at 90% there.
Now, what would be the weight factor for like chrome moly, the stuff they use on go karts?
Oh, I mean, it would be. I think the weight would be pretty substantial because it is a heavy material. I mean, that's where I would like opt to like use more like going like carbon fiber, because if you're going for strength, you can get it with a woven composite. You can get the strength, but you'll also get the weight savings. So you kind of want the best of both worlds. Like cardboard tubes, what's typically used for rockets, and my interest in this stuff goes back to when I was like in 3rd through 5th grade, when I was in the Rocket Club. So there's that. But carbon fiber tubes, they only allow for they can only accommodate only a powerful motor, right? There's only a certain amount of Newton meters you can run on like a solid fuel Estes motor. Before you're going to need like a stronger structure to run a more like exotic solid fuel mix for like a higher, for a motor that has a higher Newton meter output and a thrust burn. So if you need a motor you need to burn for like 8 to 10 seconds, but it's going to shoot the thing up at about 200 miles an hour close to, right? So that's going to be a pretty powerful motor. You're going to need a pretty powerful fuselage and structure to contain everything. And so when everything deploys out, there isn't, weird stuff that goes on. You see him go through these challenges in all his videos, so that's where I've kind of taken from what he's been doing. And I started kind of just doing my own mental tinkering, but I think browsing through that guy's archive of videos and playlists I think it's a worthy supplement to the discussion here.
Mm-hmm. Yeah, I kind of wonder if using NOS for launching, nitrous oxide, being able to save fuel before you even launch by using nitrous oxide to punch that sucker up into the sky, or punch it off the ground, and then launch your thrust vectors.
He's explored,
and then you can start your flight from there.
He's
really? Okay.
Yeah, he's explored. There's hangouts that he's done with like people who like work at like JPL. Okay. And he'd have them on a hangout, and then he starts asking them all the pros and cons of going like liquid fuel versus solid fuel versus like a hybrid. And so in his scenario, given the scale of the rockets and stuff, like the most feasible thing would be like a hybrid. And so what you would use is just what you said, nitrous oxide.
Yeah, I would think NOS would work really well, because shit, damn, it works well in cars.
Shit, works really well.
Yeah, because you can move, right? You can move what, a 3,000, 4,000 pound car at full load.
Yeah, give it a 500 shot.
Yeah.
Well, you might blow up the rocket though, right? You might blow up the rocket, right? That's a lot of impact.
No, I was talking about the car.
Yeah.
Give it a 500 shot, it'll move.
Yeah.
When you're talking about the scaled rocket, you're literally talking about a small little nitrous oxide canister. But you have to have you have to have a very precise control mechanism.
Yeah.
Well, that's where your Arduino in your Raspberry Pi comes in.
Raspberry Pi comes in.
But
right, because your servo controllers would be connected to the GPIO, which is your general purpose input output controller of the Arduino and the Raspberry Pi itself.
I mean, now he has solicited open ideas for this type of stuff because I think, like I said, if you're gonna go with what he's doing, especially with that Falcon, I think it's the Falcon 9. That's the one that has the 2 boosters and then the main fuselage. Okay, that thing's pretty damn heavy. So you know, if you're gonna really shoot that thing up to do something, like I said, you're gonna have to incorporate some more powerful like Estes. They're probably gonna be like F, G, or H class solid fuel motors. And so if you're going to go that big, then you have to start to reinforce your structures and maybe use different materials for your fuselages, and even for your like the 3D printed bracketing that he makes. You might even have to go with something more robust because it might the spent heat might even melt that type of stuff. So that's where you might need to actually use some maybe like some metal components or something like that.
Nagon, you have something you want to add?
No. I think you guys are rock and roll. It's pretty good.
Yeah, I also think about what do you call that? I want to say it's like magnetic launch capabilities. If you look at something like the S-400 missile system that Russia uses for shooting down for the surface-to-air missile system, it doesn't actually launch until it gets out of the tube. So there's a magnetic mechanism that basically catapults it up.
Yeah. Okay.
Yeah.
You know, isn't that following that same logic? Don't subs use pneumatic pressure to do the same thing with missile launches, right? Like it'll shoot it up through the water. Then once it goes, once it leaves the water, then the boosters kick on and it shoots off, something like that.
Yeah. And those torpedoes are actually pretty heavy, and they move like it's nothing. So.
Yeah, that's a lot of air pressure. Shoot that thing up like that, man. It's not. You're right. It's big. It's not heavy. I mean, it's not light.
Yeah, it's not light at all. So, following that workflow, you can actually get something off the ground pretty easily. Then, based on the success of that, I do see that this Virgin orbiter launcher is actually a quite feasible way of doing it too, because you can launch multiple times in a day, right? As long as you have enough planes, or as long as you have enough resources, you can actually get something like this off the ground a lot quicker, because a lot of these planes do come off for decommissioning purposes or some other reason, but you can buy them secondhand, like Amazon buys their Prime Air. Those planes are secondhand planes.
Oh yeah. Repurpose them.
Yeah.
So all this thing does is go up to altitude and then drop it, right? And then it launches.
Yeah, it goes as far as it can, and then it launches from there.
With this airplane, the 747, you can actually, the safe altitude that they operate on with passengers is 43,000. But that thing can go up to 49, 50,000. And you can strap on 3 of these rockets on that 47. Depends on how much fuel you put on it. You can strap on 3 of these rockets on it. So the takeoff weight.
80,000.
The takeoff weight on this thing is 800 tons.
So 80,000 is the ceiling, right? Before you get into actual space, right?
Yeah, I think that's the you're entering space when you go up to 80. Space actually, well, yeah, it's about the beginning, yeah. Because the Mach 2, Oh shoot, what's the name? I forgot the name of that airplane used to fly Mark II passenger flight. Concorde. That used to fly like
Okay.
60. That used to fly around 60.
Okay.
So yeah, when you get
That,
it,
and that was a supersonic jet.
yeah.
So now this gives us, all of this information has given us a good perspective on what to expect if you're trying to launch something into space from a grassroots standpoint.
Yeah,
I think a lot of African countries. I think a lot of African countries are relying on China and the and Kazakhstan. Since these former Soviet states, Kazakhstan has a very good space program too, and they seem to be very cost effective. I guess that's an alternative to Russia, but um, not sure what the value is of their of their future at this point with all the political restructuring going on over there. But what I'm saying here is I think there is a window of opportunity if we so put our heads together to do something like this.
the old technology. Say if even if you use a old technology, um, the testing was done on it, so you can pretty much say, well, you make this rocket this long, with this dimension, and then you use what new materials are available to make the rocket with. You can launch it because the like I said, the United States spent first. You guys talking about the Germans. The Germans invested a lot of money in making rockets flyable. They can hit London from Germany, you know, and that's with a V2. No intelligent controls whatsoever. You know, that rocket didn't have any computers on it that calculate the trajectory and all that. Now we have all that information. So African countries should be able to build their own. I mean, even if they start off with the old, I don't know, missile, like the
I
300.
think, yeah, if I remember correctly, the V2 had a metronome on it and some kind of gyroscope. I think that was the extent of its computing functionality. So they had some kind of measures where they would set the metronome in the gyroscope inside, and then it would determine where it should land based on how they preset it.
That's exactly correct. They knew exactly what the mileage was. They knew exactly where they were going to. They did have a gyroscope to point it and make sure it went into the direction that they wanted to go. And as soon as it hit that certain distance, the rocket would actually cut off, and it would fall and drop right into that, right on that area. Exactly what they were doing.
Mm-hmm. You were gonna say something, D?
Oh, I'm sorry. Go ahead.
Yeah, I was going to say that we can actually use missile technology. You know, like I don't know if you'll be able to find what kind of missiles they put on submarines or whatever the case might be, but with the like SpaceX today,
They were using in submarines. They were using with the Polaris missile, which
right?
was a small ICBM basically.
Exactly. Yeah. So with all that information out there now, you can go on YouTube, pull up that information, teach it in a classroom, and university students can start building the rocket. The countries can start in the university with these people building their rocket and getting it to low Earth orbit, and from there you have everything. You're just adding more technology to it to make it to pinpoint the accuracy to get it to where you want to. Once it get out there to control it, you can move it around space and all that. You can do that. And you can do all of that. That's how. Who do you think a lot of space people come from MIT, you know, Cal, you know, these engineers.
Yeah, yeah, Complex, go ahead.
I posted a link in the chat. This is I was meaning to send this one in the email to add to the docket, but too late to do it. But this is just with regards to drone startups, flight plans to reshape rural Africa. So if you guys just think, well, I know you guys don't think we're talking just fluff, but this is just more. It's more information to digest because the subheading on the video, I think it's a CGTN piece. Excited drone entrepreneurs are pitching their businesses in the hopes of connecting with new partners and funding sources. The businesses could help revolutionize business in rural Africa. These are people who are out in rural Africa, and they're looking at they have ideas on how to use drones to improve things in rural Africa. Look, trust, man. You know, I'm plugged. My ears are plugged.
Okay.
So check it out, just to see what it is that what it is that we're talking about, man. Because this is some real stuff.
Yeah, I'm definitely hip to the game. You know, I've been looking at this stuff for a few years now. I've always been into to the electronics aspect and radio control cars, radio control planes, helicopters. I still have quite a few of them in the basement, just not doing anything with them. But I haven't gotten into rocketry as of yet. I always looked at them, but I wasn't a big fan of the you know, small scale rockets. I always wanted, you know, the big stuff. I was always into the big time. I don't like small RC cars. I didn't buy the cheap stuff, man. I bought the big stuff. So I like to go big when I invest into anything. So that's my perspective on it.
Same here. You know, I think my approach is more racing oriented. That's how I am with it. But you know, yeah.
Nagone, you have any closing thoughts?
No, not really. I just, you know, I think my orientation was always a bit on the electronic car side. You know, remote control, some of that stuff. I loved that a great deal, and plus I was big into, you know, in auto racing. You know, like that was my thing. I think we conversed on that before, but yeah, that's kind of was my interest. But rocketry is definitely something I've always liked. Always had a huge interest in it because I've always had a big interest in outer space and just, you know, the planets and all that, and traveling throughout the universe and thinking about how to travel greater than light, you know, greater than light speed and all this kind of stuff. I was always kind of into that as well, but not that a rocket would actually do that. Help me to do that, but certainly, you know, the thought of rocketry and all that is something that I've been seriously into as well.
Mm-hmm. DE, you have any closing thoughts?
So, as far as this technology goes, I wanted to kind of, I tried, let's say, not with the drone technology and all that, but space technology, especially as aircraft technology. I try to get people interested in here. Me now, I decided, you know what? I'm relocating to Africa in about a year or so. Sometime next year, June, July. And the same program that I wanted to set up here, I'm going to set up there. It's either going to be in Tanzania or it's going to be down south in Namibia. Wherever I go to live, that's where I'm going to do it. I'm going to get black kids involved in this, even if I have to pay them. That's what I plan on doing.
Wow, that's awesome.
All right. Just anything in the chat before we close out? No, other than that, I don't see anything in the chat. But thank you all for joining us. We do have a hangout tomorrow with Business Wealth and Power, talking about cannabis.
No, I think it might.
And
hey, Mike, can you hear me? I think that's next Sunday.
Yes, sir. Oh, next Sunday. Okay.
Yeah, next Sunday. Because that's going to be a special one, man. So what we're gonna do is, for that one, we're gonna go into like the indigenous applications and uses of cannabis throughout history.
Okay.
So that'll be next Sunday.
All right. Well, we will be back on Monday then for Space and Technology. And just as FYI, I do offer IT mentorship. So if you're trying to get into IT, or if you're already in IT and you want some guidance, I can help you out with that through mentorship. You can always hit us up at the Black Brain Trust's email, or leave your comments after the video is over, and I'll actually respond to it.
All right.
All right. So you all have a good weekend.
All right.